Welcome! In this movie I would like to show you how to perform analysis of trabecular bone structures using the Imalytics Preclinical software. Let me open the software first. You can find an example dataset under Tutorials, CT, Trabecular bone, load example dataset. Let me open the 3D rendering. And what you see here is a CT scan of a bone of a sheep knee. And I will close the segmentation because we want to generate it by ourselves. And you can see that we have different trabecular structures, and we want to also different regions, and when we want to compare them, so the inner part with the outer part. And first let me segment the bone structures. Therefore I will add a class bone. Then I hover with my mouse over the bone, and you can see the intensity here in the right corner, so it's very high. That's why I will pick a threshold of 4000. And what you also see is that the data set is quite noisy and we really don't need this high resolution, so we will perform a Gauss filter. Therefore I will undo my segmentation, go to edit, filtering, Gauss filter 1, and now I can perform the thresholding again, and the data set looks way better. Okay, we can now measure some parameters, for example the trabecular thickness, like here at 0.128, or we can also measure the gap between the bones, the bone wall gap, 0.5. And you can see that this outer region looks a little bit more spongy because the gaps are bigger than here in the inside. And we can also calculate this in a little bit more accurate way by using the bone model of the Imalytics Preclinical software. But to do this, we have to define a region first. Therefore, I will add a class A. Go here to our Create Region module of the mouse action toolbar. I will use a cylinder with a diameter of 4 millimeters and a length of 4 millimeters. I will place it here. Looks good. And I will place another one here. Call it B. Looks also very good. Okay, and now we can calculate, for example, the trabecular thickness here for the input class A. Our threshold again is 4000, and you see 0.028 centimeters. And we can also calculate it for B. (0.027). But it's easier when you just click on bone statistics, because then all the parameters are calculated for A and B, and you can directly compare them with each other. And as you saw before, the trabecular thickness is similar for A and B, but the trabecular spacing, it's bigger for A, 0.05, than for B, 0.03. And this is what I meant when I said that this looks more spongy than the inner part. But how does this actually work? So what the software does is it computes a so-called local thickness map. And I can do this for class A, for example. When you go to bone local thickness map of input class, it's now shown here as overlay. So it's fitting a lot of small spheres actually into the bone region here, and then it's computing the mean of that. And in a similar way, we can also compute a local thickness map for A, or the local separation map of the input class. This is now shown here. And this is the map for the trabecular spacing. And then it's fitting the sphere into the spacing and computing then the mean of that. And this analysis can also be performed with BoneJ. You maybe know this program, and we also did it. And we compare the analysis of the Imalytics Preclinical software with BoneJ. And you can find the results in the white paper for the trabecular bone. So you can go to tutorial, CT, trabecular bone, show white paper. Let me open it. Whoop. It's here. So this is the comparison between the trabecular thickness calculated by BoneJ and by the Imalytics Preclinical software. And they both have very similar results. So if you're interested in that, just check out the white paper. Okay, what we can also do in the bone model, we can create some test data. And then create test data, multiple spheres, 3 spheres per row. And what does this example does, it's just an array of a lot of spheres, and we know the surface of the spheres and their thickness. And so the solution can be computed analytically, and it's a nice example to test if the software is working correctly. So you can see here the parameters, the known versus the computed one, and they are very similar. Okay, let me show you the spheres. You can also create some other test data. And yeah, I hope this helps. Thanks for watching the video. Bye bye.